Hello, good evening to everyone. My name is Rajnandini, and today we are going to discuss about one semiconductor device that is called SCR. SCR is called Silicon Control Rectifier. So we are going to discuss about that SCR. Okay, this is called Silicon Controlled Rectifier. Okay, so this means that controlled rectifier, we can control it in a better way. Okay, so let us try to know it. How we will try to know first its basic construction. How does it look? So this looks like it is a four layer semiconductor device. It will have four layer, one two three four. What kind of semiconductor it is using? P type semiconductor and N type semiconductor. Again, P type semiconductor, N type semiconductor. We know that diode is a PN junction diode, right? PN. It is made with P and N type semiconductor. Here we are taking two PN and PN. When two PN semiconductor elements or two, we are taking here the four layers of semiconductor element to make it a PN junction diode. So it is a four layer component. Here this is one junction, we can say it is the J1, this is J2, and this is J3. So it has three junction, four layer, and three terminal devices. So in diode we have two terminal, anode and cathode. Here there are three terminal, one, two, and three. Okay, this one is the gate, anode represented as A and cathode represented as K. Okay, silicon controlled rectifier, it is a this is a nothing but the electronic switch, DC electronic switch. This is the DC electronic switch. It acts as a DC electronic switch to control high power current, high power current. Okay, as it is saying it is a rectifier, means it converts AC to pulsating DC. Okay, it converts AC to pulsating DC. So this is how the PN junction is constructed. We are combining the P type semiconductor to the N type semiconductor. Again P type semiconductor we are adding, and then N type semiconductor. Means there are four layers of semiconductors. Four layers of semiconductor. Okay, four layers of semiconductor, and there are three junction. Here PN is meeting, it means it is creating one junction. Here again NP is meeting J2 junction and PN, then three junctions. So it has three junctions, and it has three terminals. Three terminals. Okay, so it has three terminals. Basically we say SCR is a thyristor. So we use SCR because it has better control. We can like in a diode, we are it also act as a switch, and we can control it. But in SCR, in diode, there is after knee voltage, the current exponentially rise, right? So here in silicon control rectifier, we can control the current in a better way. We know exactly at what current the SCR start to conduct, and there is the better control than the diodes. So this is the reason we use SCR, and SCR is used when there is the matter of controlling high current. Okay, so in that case we use SCR. This is the construction of the SCR. Okay, this is the construction of the SCR. This is represented as cathode. Cathode means the negative terminal, and the p type here, this is represented as anode. Anode means the p anode, it will be connected to the positive terminal. And here again, the p type, the third layer, is represented as the gate. Okay, so gate is, we say it is G, is represented as G. So now let us try to understand its various modes of operation. Okay. Now let us try to understand its various modes of operation. So basically there are three modes of operation. In There are three modes of operation in SCR. So let us try to know what are the three modes of operation. So modes of operation. Modes of operation. What are the various modes of operation in SCR? So there are basically three modes of operation. The first one is called the forward blocking mode, and second one is called reverse blocking mode, and the third one is called forward conduction mode. So let us start with reverse blocking mode first. Okay, the first one called reverse blocking mode. Okay, what happened in reverse blocking mode? As it is said, reverse means our anode and cathode, we will connect it in the reverse bias. Like it is the type P type semiconductor. Okay, then this will be connected. This will be connected to the negative terminal, and here N type semiconductor, this will be connected to the positive terminal of the voltage source. Okay, this will be connected to the positive terminal of the voltage source. Then here what we find, our junction, since it is connected to the negative terminal, means J1 is reverse bias. J1 is reverse bias. Similarly, if we see the J3 junction, here this N is connected to the positive terminal, means our J3 is also reverse bias. Okay. Now if we say, if this one is N is connected to the positive terminal, means here J2, if we see J2, so J2 will be our, it will be in what? It will be in forward bias. Okay. So in this is the reverse blocking mode. So in this condition, the SCR is in reverse mode. Okay, and very small reverse leakage current is flowing through the SCR, and if we further increase the voltage, if we further increase the voltage source, then what happen, the breakdown will occur, and at the constant breakdown will be occur, that is and after that, at the constant voltage, in reverse direction, the current will start to flow. We will understand this through the VI characteristics also. Okay, so now the second one that we are going to discuss is now forward blocking mode. Okay, what is happening in forward blocking mode? So let us try to understand. Now in forward blocking mode, we will connect the anode of this SCR, P side of the SCR, to the positive terminal. Okay, positive terminal, and cathode here N type of the SCR with the negative terminal. So here what we see that our P type semiconductor, here P type semiconductor here connected to the positive side, and N type semiconductor here connected to the negative side, means our anode and cathode both are connected in the forward bias mode. Okay, forward bias. So our J1 and J3, this will be in forward bias. Okay, forward bias, and our J2 will be in reverse bias. So here we will keep the gate open. We are not applying anything there. Okay, we are not applying anything there. And in reverse blocking mode also, we are not applying anything there in the gate. So here our J3, so our J2 is forward bias, but that is the reverse blocking mode, and reverse leakage current is flowing, very small reverse leakage current is flowing through it. Now in the forward bias, what is happening, when the P type semiconductor is connected to the positive side and the N type semiconductor is connected to the negative side of the voltage source, then J1 and J3 will be in forward bias, and J2 will be in reverse bias. In this situation, leakage current flows through the SCR, but the SCR will not conduct, because because the voltage is not able to cross the breakover voltage. Okay, so in this case, our SCR is actually not conducting. The and here the SCR act as a open circuit. Okay, SCR acts as open circuit. Fine. Now the next one is forward conduction mode. What is happening in forward conduction mode? Again, we will connect the P type semiconductor to the positive terminal and N type semiconductor to the negative terminal. Okay, then our J1 and J3 will be in forward bias. J1 and J3 will be in forward bias. But this time we are not keeping the gate open. Okay, we are applying the positive positive voltage source, positive terminal. We are connecting the positive terminal to the P side, that is the third layer of the SCR, and negative terminal to the cathode. Means we are giving the positive pulse to the gate with respect to the cathode. So in this case, our J2 will be in also in forward bias. Okay, our J2 will be in forward bias. So what happened when we are providing the positive pulse to the J2? Here third layer means gate. When we are applying the positive pulse to the uh, gate, then it helps the it helps the SCR to cross the breakover voltage, and after that the current start to conduct. Okay, the current start to flow. And if we increase the positive pulse in the gate, if we increase the positive pulse in the gate, we will find that the crossover voltage is the breakover voltage is achieved soon by the SCR. And further, if we are increasing the gate current, we find that the the breakover voltage is achieved soon, and our SCR will start to conduct soon. So on increasing the gate positive trigger, we find that our SCR start to conduct quickly. Means what we are trying to see here. So means we are able to control the SCR in a better way. We know how to control it. If we are increasing it, means the we are achieving the breakover voltage. Our breakover voltage is less, and it starts to conduct. Okay, so these are the three modes of operation in SCR. So now let us see the VI characteristics. Okay, so let me wrap this one. So let us now see the VI characteristics of SCR. Okay, here the anode current, positive anode current, negative anode current. Here positive anode current, negative anode voltage, positive anode voltage. Now let us try to understand it according to its mode of operation. First we discuss the reverse mode, right? Reverse mode operation. At that time we were keeping the anode, and anode we were keeping it reverse bias. Means P is connected to the negative terminal with respect to cathode. So we were getting the J1 and J2 as reverse bias, and since the gate was kept open, so we find J2 as forward bias. In that case, a reverse leakage current was flowing. Okay, and if we keep on increasing the voltage, we will find that at a particular voltage the uh, there is a breakdown of the components. Okay, breakdown of the SCR occurs, that is represented as VBR, negative VBR in a negative direction. So after that, at a constant voltage, the SCR start to conduct the electricity in the reverse direction. So this happens in the reverse blocking mode. Reverse blocking mode is this much, and when if you are increasing the voltage beyond the VBR, means beyond the breakdown, then the current start to flow. Okay. Now come to forward blocking mode. In forward blocking mode, we kept the gate open, and we connect the p-type semiconductor, the anode of the silicon control rectifier, to the positive terminal of the voltage source with respect to cathode. Okay, and keeping the gate open. In that condition, our J1 and J2 were in forward bias, and J2 J1 and J3 in forward bias, and J2 in reverse bias. In that condition, the there was a leakage current flowing through the SCR. Okay, there was the leakage current flowing through the SCR, but what was happening? It was not able to cross the VBR. it was not able to cross the VBO. VBO means VBO is the breakover voltage. Means in SCR to conduct the it must cross the breakover voltage. Okay, it must cross the breakover voltage. So it was not able to cross the voltage. So very small very small t here, you can say very small leakage current, very small leakage current is flowing, and not current is flowing through the SCR. To to uh, to get the SCR conducted, we connect the we give the positive pulse to the gate, and in that condition J1 and connecting the anode to the positive terminal of the voltage source with respect to cathode, means J1 and J3 are in positive forward bias and giving the positive pulse to the giving the positive pulse to the gate with respect to cathode, then J2 will also be in forward bias. So that is called the forward conduction mode. In forward conduction mode, what happened when we are applying the voltage, when we are applying the positive pulse to the gate, so it in turn get this junction B2 breakdown, the junction at the breakdown occurs at the junction, and what happened, J1 J and all are in positive, all are in the forward bias, and breakdown occurs in J2, and this led to the conduction of current. Okay, this led to the conduction of the current through the SCR. Means when there is a positive, when there is a positive terminal, when there is a positive pulse given at the gate, so the SCR start to conduct. It will cross the breakover voltage, and it conducts in the ohmic region, and it starts to conduct. Here the minimum current at which the SCR start to conduct, and after that, even if we are removing the positive pulse from the gate, the SCR will remain, and it will remain open. Open means it will remain on, and it will continue to conduct even if we remove the positive pulse on the gate. So that current, the minimum current at which the SCR start to conduct, and it remain conduct, and it will remain conduct even if we remove the positive pulse at the gate. So that current is called here, that current is called, we can say it is the, that current is called latching current. Okay, my this one is not working. Okay, that current is called latching current. Okay, and one more current is related here, that is called the holding current. Now our SCR is on. Okay, now it is conducting the it is conducting, and the current is flowing through it. Means now the SCR is on. Now what happened? It will continue to flow, the flow of current will be continuing, but when the current comes below certain current level, then the SCR will stop to conduct. That current is called holding current. Okay, means the minimum current below which the SCR stop to conduct, that is called holding current. So here if we see the latching current, the latching current is more than the holding current. Okay, And here one more thing we need to discuss is, like here we applied the positive trigger. We have given the positive trigger to the gate, and it's helped to cross the breakover voltage, and after that it start to conduct in the ohmic region. Here it means we are here giving Ig. Okay, here Ig is given. Now, if we say, if we increase the positive, if we increase the positive voltage at the gate, okay. So what happened means our Ig is more. Ig is more means when the gate current is more, if we increase the gate current, we will find the breakover voltage of the SCR earlier, and in that case we will achieve the breakover voltage earlier, and again it will start to conduct. Similarly, if we keep on, if this is Ig and this is Ig1, and if we keep on increasing the gate current Ig, we'll find we are able to get the this is VBO1, VBO2. So we are getting the breakover voltage earlier. Okay, means in the less voltage we are able to make the SCR to conduct current, right? To flow the current at the lower breakover voltage. So by increasing the here Ig2 is more than Ig1 and Ig, means by if we are increasing the gate trigger or gate voltage, we are getting the voltage breakover voltage, we are getting it earlier, and at the less breakover voltage we are able to make the SCR to conduct, and the flow of current is happening in the less breakover voltage. So this is the latching current. We say latching current is the minimum current that helps the SCR to conduct. Okay, that is the latching current, and holding current is that current below which the SCR will stop to conduct. This is the holding current. Latching current is always greater than holding current. Okay, now we will talk about the various triggering method. What are the various triggering method? Here we have applied the positive pulse to the gate. So this method is called gate triggering method. The most common used method is the gate triggering method, and this is very useful, and through gate triggering method we can control the SCR in a better way. Okay, now I am rubbing this one. So here we are saying, now let us see the triggering methods of SCR. Let us see the triggering methods of SCR. So the first one that we read was gate triggering method. What was happening in gate triggering method? We were providing the positive pulse to the gate. That is called gate triggering method. The next one is by increasing the anode voltage. Voltage triggering method. This is also called voltage triggering method. Okay. So our purpose was what? In SCR, we were trying to make the SCR conduct by by increasing the crossover voltage. Means if we increase the anode voltage and it is crossing the crossover voltage, then our SCR starts to conduct. Means our purpose is to uh, is to is to pass the crossover voltage, and if you pass the crossover voltage, the SCR start to conduct. Okay, now the next one is temperature triggering. Temperature triggering is used in high voltage DC. Another one is light triggering. And the next one is dV by change in voltage, dV by dt triggering. Okay, dV by dt triggering. So this is all we have in this video. I hope you have understand. I have hope and enjoyed this video. And thank you for watching. Keep watching my video. And if you want me to make more videos, then you can tell me the topics at on which topic I can make the next video. And keep on watching and keep supporting. Thank you so much.